So now we first take a look at the our last homework, okay, which is language model ATD and CK. So here we have introduced the fine-tuning mask language model by using Hugging Face. So please take a look at this chapter 7.3, and I think you should run this Colab code. Okay, try this code, and then we need to modify it to do your homework 8. Okay, so first thing, next thing is you have to select your own built-in language model and try to fine-tune it with additional corpus, just as the template this fine-tuning mask language model did. Okay, so we'd like to make a fine-tuned model to learn cybersecurity knowledge. Okay, so right now we need to choose some cybersecurity related and professional document from the website which is called MITRE. Okay, so first we take a look at this website. So here for MITRE, basically let's take a look at this one. Okay, basically MITRE is a organization which here they define a matrix, okay, which is called technique procedural matrix, okay, but it has a name called MITRE ATT and CK, and it means when they analyze an attack in an enterprise, and they divide all the behavior into 14 different categories, and they call it tactics. So reconnaissance is one of the tactics, initial access, execution, and so on and so forth. Okay, so let's take a look at this one. Okay, reconnaissance. Its ID is TA0043. So here is the definition of reconnaissance, and it has several techniques right here. So there is a definition of each techniques. Okay, so let's take this one for example. Okay, active scanning is one of the technique, and here is the definition of active scanning. And we expect that and in the entire matrix there are 14 different tactics and more than 400 techniques, and even we have more sub techniques. So for those documents, they are quite their knowledge is about different behaviors of an attack, no matter it is ransomware or no matter it is physical attacks or something. There are a lot of different definitions right here, and we expect those documents are more professional than Wikipedia documents. Okay, so we'd like to that language model to learn those cybersecurity knowledges. Okay, so very similar to the example of IMDb, right? We want them to learn these things. So the next thing is that in this website, it provides several different right here Excel files, and those Excel files, they have a very nice and well organized rows and columns to define what is tactics and what is techniques. So here I show you some examples right here. So we have two different Excel right here. We download them and we read it to a data frame. And as you can see that here we have the definition of the first tactics TA0009, and its name is collection. And here is the definition of description of the collection. Of course, it is a very long sentence, but we it is dot right here. So here's the definition. So right here, collection, and here is the definition. So we would like to learn those knowledges. Okay, so basically you need to take a look at this fine-tune mask language model and to replace the IMDb dataset by using the dataset right here. So we expect the fine-tuned model has more knowledge about cybersecurity. So after that, okay, so here we have the instruction again. So parse the Excel files and extract the name and description as your additional corpus. The name can be used as a label and description can be used as text. Or you simply just want to perform MLM, so you simply just use the description right here. So try to find your model. Okay, and as we mentioned, you don't have to push your model to Hugging Face. Okay, you can simply just use the code lab result. And after that, okay, right here, since we have two models, okay, one is the original one and the other is the fine-tuned one, okay? So the first thing you need to do is trying to find some testing data set to calculate the perplexity. And my recommendation is that in the matrix, okay, and you can always find the definition of technique, right? But also you can find some additional information right here. They are all related to this specific techniques. But notice that we only train this part, but we don't train sentence in this part. So I recommend that let's try some downstream task, okay, and see if what is the changes of your fine-tuned model, okay, against the original model. So here is the fine-tuned mask, right? So I recommend you prepare additional sentence. I think they should be larger. The size should be larger than 100 sentence, and from some sentence right here, okay, so you can simply just random click some techniques and collect some sentence from, for example, right here, and we can perform zero-shot classification just I showed you before, and you can perform MLM, and that we can see if the perplexity decrease, and ideally it should decrease, right? Because your new model, fine-tuned model, should have more cybersecurity knowledge, so the perplexity should decrease. Okay, that is the one thing. And the other thing is that I recommend you use, for example, zero-shot, right? You should try one of the pipeline. Okay, so you may try zero-shot classification, so that, for example, given a sentence, and you should tell me which tactics it belongs to, because the tactics is written right here. You can check against with the tactics right here. Okay, so again, you have two models. You can use this sentence right here to ask the original model which tactics it belongs to, and again ask the new model which tactics it belongs to, and we anticipate that the new model, the fine-tuned model, should have better classification rate, even it is zero-shot classification. Okay, and again, you can design your own downstream task by using any pipeline you can find in Hugging Face. So that is your homework number 8. So basically, what pipeline you would like to use, or what additional design you would like to use, it really depends on you. Okay, but I request you to perform fine-tune by using the tactic and techniques definition on the language model you select. And you have to provide perplexity and a downstream task. Okay, that is your homework number 8. And as you can see in your class website, we have project, right? So project, the content of project, you don't have to give us your code. You simply just need to upload a PDF file, which includes your title, goal, and your design downstream tasks, and where we can find your complete code. Maybe you can provide your GitHub repository, or you can give us your shared code lab file. And you have to find a security related data set by yourself. And you need to tell us how do you perform data preprocessing and what kind of model you use. And we strongly recommend you use language model and some conventional model, okay, to perform some downstream task. And of course, if your downstream task is quite simple, which you can simply just use pipeline, which is okay, but we recommend you write your own downstream task. Usually that should be some classification task or cluster task, and you have to show us your result. Okay, if you want to leverage Orange, which is okay, and that the language model you used should output vectors, and you can collect those vectors in for example, a CSV file, and you can input the CSV file to Orange to perform further analysis using Orange. But if you like to use Orange in your in your project, you have to screenshot your workflow in your PDF report. So basically, homework number 8 and homework number 9 is quite similar. But homework number 8, I recommend you use a template by Hugging Face, and I provide you additional cybersecurity corpus. But in your project, you have to decide which corpus you want to use, which downstream test you would like to use, which model you would like to use, and what additional models, for example, SVM or linear regression you like to use. So basically that is. Since these two, this project and this homework might need some more time, so basically you can write it from now, okay? But the due time will be the day we have project demo. You have to come to one student form one team so basically you have to do the project on your own, and you please come to a classroom in a demo day, and we will randomly select students to present your project. You don't have to prepare any slide or a presentation file. Simply just use your PDF file to let students know what is to know all the information, all the things right here. Okay, so that is your project. And so we have only 3 things left. The first thing is this homework, and the other is the project and the final. So for the final, again, we will announce the final collab file on our class website, okay? And we will try to minimize the number of codes you need to write in your final collab file, because you need some time to write your homework and your project. So basically the final will be some questions about machine learning and the neural network and language model concepts. Okay, so we will announce it later. So basically we have 3 things need to do: homework number 8, your final and your project. So that's it. Okay. So in this hour, one additional thing is that packet. And I assume you already know what is network, what is packet, and the protocol stack of networks. So I would like to teach you how to analyze packet in this codec file, which is D3. Okay. For example, here I provide a suspicious packet. Okay. So that's it. And you need to install package with SCAPY. Okay, SCAPY, and it can help us to analyze packet. So for example, this specific function, okay, sniff 100. That means it will capture 100 packet from your network interface card. Since we execute this codec file in Google's Colab server, it will capture 100 packet on Google's machine. Okay, so after that, you can see that it has customized data structure with this packet list, and you can simply just type them to see, okay, that is Ethernet packet. Okay, and you can simply just save the packet. Okay, or show this packet. So for example, we have two packets right here, and you can see that it will print the packet in a more friendly way. So here's the Ethernet headers. We have 3 different fields: destination MAC address, source address, and the type, which is IPv4. So IP headers will be attached after, will encapsulate after Ethernet, right? So here's the version. The 5 means the length of the header. So it's the 5, but the unit is 32 bits. Okay, so in total there will be 20 bytes. Okay, quality of service, the length of the packet, the ID for segmentation, round trip, TTL protocol, and the protocol 6, that is a TCP packet, right? Something like that. So in TCP we have a lot of different fields, and in the layer 7 payload, and it looks like HTTP packet. Okay, so this function will print the packet in a more convenient and friendly way, so you can read those packets. Okay, or you can simply just summarize the packet, or you can simply just print all the layer 7 payload in this way. Okay, there are some other high-level functions, so make sure if you really want to analyze packet, make sure you take a look at this list. Okay. Second, I want to install a packet program which is called P0F, and actually it means profiling. Okay. So you can profile the packet you just collect, and it will analyze the packet one by one. And what profiling does is that it will try to guess what operating system you are currently using, and what kind of application, for example, right here, what kind of application or server you used in that server. It will try to guess. How possible a function, a program can guess what operating system you use by simply just take a look at the packet it transmitted? That is because, okay, that's because there are certain field, for example, TTL right here in the IP header. There are certain field. Of course, we know what TTL means. That means every time this packet path through a internet router, this number will decrease by 1. Okay, but in the IP specification, it did not specify what initial value it should be. So for implementation wise, Microsoft and Linux and maybe Apple, those different operating systems, they have different initial value of this TTL. And of course, they are lots of field. They don't have specific initial value. So operating system need to define what exactly the initial value it should use, and different operating systems have different initial value. So by simply just analyze the packet it transmit, we can guess which operating system it uses. And even more, for some layer 7 protocol, it says okay, it is an Intel Mac OS X. So sometimes it is just very simple. It simply just take a look at the layer 7 payload. You can guess, or it is specify. It indeed specify what application, what server, what OS it use. So the P0F, okay, it can perform such kind of what we call operating system fingerprinting, OS fingerprint. Okay, so that is how it works. Okay, so again, that is the second thing. The third thing is, what if we have two packets set? Okay, this one is the normal one collected from Google's network interface card, and this one is the suspicious packet provided by me. Okay, so we concatenate them together. Okay, so right here we have in 162 packet. So I think the one of the good application is if we can create a neural network or a language model with a classifier and trying to separate suspicious packet and the normal packet. But as you can see that in the packet, okay, so let's take a look at this one. So we can so we simply just print them, okay, by using this. But here we need some more complicated parsing way to convert the packet to a data frame. Okay, so please take a look by yourself. Okay, so here is an example. Here we have a packet, and here those are its layer 3 headers, layer 4 headers, and here we have additional layer 7 payload right here. And you can see that some field are numeric data, but some field it looks like categorical data. So for numeric data field, we simply just keep it, okay? But for categorical data, we can simply just use one-hot encoding to replace this categorical data, right? But for some text-based data, so we can use language model to transform those text-based data to vectors, right? Although, for example, BERT model may not know what exactly HTTP protocol is, but it has certain capability to transform text into vectors, numeric vectors. Okay, and as we mentioned before, BERT or BERT-based language model, their dictionary has they need to perform preprocessing by using tokenizer, right? Tokenizer will split all the word into word pieces. So even if there are some unknown text in the original D07 payload, BERT has capability to tokenize them. So in this case, for the capital L, capital Z, small r, capital F will be word pieces, even if we don't know what exactly it means, right? So we can convert text-based data to vectors. So in this case, we have numbers, we have categorical data, we have text-based data. So after we perform transformation, all of them become numeric data. So after we have those numeric data, then we can perform any analysis. We can use SVM, we can use transformer, we can use logistic regression, linear regression to see if it is suspicious packet or it is a normal packet. Or we can perform clustering, hierarchical clustering, or DB scan, right? We can see if attack packet, they are clustered together or not. So we can perform whatever we like. Okay, so after that we have some example to analyze packet. Okay, but that is the reason why we teach you how language model works, and after that we show you how to analyze packet. So basically, for analyze security data, sometimes those security data are numeric data, so they're quite easy. You can simply just apply SVM, neural network, convolution, RNN, right? So for categorical data, 1 hot encoding, 1 hot 1 gram, 1 hot 2 gram, 1 hot 3 gram. Okay. For text-based data, or even for binary data, you can use language model to convert them to a high-dimensional space. So after that, we can concatenate all these 3 different types of data to perform further analysis for classification or for clustering. So we stop right here. So we will have even more codes and the concept will be discussed the next week. Okay, so we stop right here this week.